Hey mathematics learners, welcome to Distance Learning with Lee, where I make learning mathematics super easy. So on today's video tutorial, guys, we are going to be, diving into the topic of surface area. Okay, I'm going to be defining what is surface area, how do we come up with the formulas that we use to help us calculate the surface areas of your rectangular prism, your cylinder, as well as your cube. And we're also just going to be looking at a few examples together where we will be basically applying those formulas, okay, to help us calculate the surface areas of the given shapes. Okay, so before we get started with today's video tutorial, guys, please make sure that you've watched the video tutorial that I've done for you guys on area, because this lesson is a build up from that lesson that I've done for you guys on area as well as perimeter. Okay, you need to understand what is area before you will be able to understand what is surface area, and you also need to understand how we calculated the circumference of a circle, because you guys will basically need that, okay, when calculating the surface area of a cylinder. So please make sure that you watch those two video tutorials that I've done for you guys, where I've explained area as well as perimeter. Okay, you need those basics. So before we get started with today's video tutorial, guys, please make sure that you are subscribed to the channel. Please make sure that you click on that notification bell so that you get notified every single time I upload a video tutorial, guys. Also, please don't forget to give all these video tutorials a huge thumbs up. That really helps the channel grow, and it helps the channel to reach more learners that want to better their mathematics marks. So without any further ado, guys, let's get started with today's video tutorial. So what is surface area? Okay, when we're calculating surface area, guys, we are just calculating the total areas of all the faces of a shape. Remember, when we were basically calculating area, I did mention, okay, and I gave you guys a nice example that if you had a table and you were to put a piece of paper on that table, and I was to basically ask you, what is the area of that piece of paper? Basically, what you would be calculating is the amount of space that that piece of paper is taking up on that surface or on that table. Okay, so when we're calculating area, guys, we are just calculating the total space that is taken up by a flat shape on a particular surface, or the total space that is just taken up by a flat shape. Okay, so now when we're talking about surface area, what type of a shape are we actually working with here, right? It's very important that you guys note that when we're calculating surface area, we are actually working with your 3D shapes. Okay, we are working with your rectangular prism. This is a 3D shape. You're working with your cylinder. This is the 3D shape. We're working with your cube. This is the 3D shape. You're working with a triangular prism. This is a 3D shape. So we're working with 3D shapes here, right? And we're just trying to determine, okay, what is the total area of all the faces of that particular shape? Okay, so what do I mean by faces? So now I've got a box of benylin, all right? So I'm going to make myself a bit big there. I've got a box of benylin. Okay, I've got flues, so you guys will see with the 3D shapes that I'm using here that yeah, it's bad. Okay, so I've got a box of benylin here. Okay, and this is a rectangular prism. If I said to you, calculate the total surface area of this particular shape, okay, what would we do? Okay, already I mentioned that when we're calculating surface area, guys, we are just trying to determine what is the total areas of all the faces of that particular shape. So how many faces does this shape have? Okay, how many faces? We've got one, two. So the top and bottom is two. The side and side is another two, so four. The front and the back is another two, six. So this rectangular prism has six faces, okay? And those faces are the top and the bottom face. You see, that's a face. That's another face. Okay, these are all the faces of this particular shape. So when we want to calculate the surface area of this particular shape, we calculate the area of the top face and the bottom face, okay? The area of the side face and that side face, the area of the front face and the back face, and we would just add all those areas up together to give us the total surface area of this rectangular prism. Okay, if we wanted to calculate now the surface area of a cylinder, okay, so you can tell here that I've got now this cylinder. Okay, this is a cylinder. Okay, how would we go about calculating the surface area of this particular cylinder? Okay, we've got that face there. Okay, we've got that face there, and we've got that face there going all the way around. Okay, so if we want to calculate the total surface area of this cylinder, we just calculate the total areas or the areas of all the faces of this shape and just add them all up together. Okay, so you guys need to basically understand that point is that you're just calculating the areas of all those faces, okay, and you want to add them all up together, and that will give you the total surface area of that shape. Okay, so for example, okay, we started off with your rectangular prism, okay, your Benelin box. If I asked you to calculate now the surface area of this box, all that you need to know is what are the dimensions for this box? What is the length of this box? What is the width of this box? What is the height of this box? Having those dimensions of this box will just make it easy for you to calculate now the surface area of the box. Okay, so let's say, for example, we are given this box, okay, and we are given length L, width W, and height H. And I asked you to calculate the total surface area of this particular box. What would you do? We already know. We just need to sum up all the areas of all the faces of this box. And that will basically give us the surface area of this box. Okay, so now the trick in calculating surface area is just being able to identify which faces share the same dimensions in this case, okay, when you're dealing with your rectangular prism. So we already see that if you're dealing with your rectangular prism, okay, if you look at the top and the bottom face, you'll actually see that they share the same dimensions. They have the same length and the same width. Okay, so if we had to calculate now the area of the top and the bottom, okay, that area would basically be the same. Okay, so remember, how did we calculate? Okay, so you just know if you wanted to calculate surface area, we already know that surface area is equal to the total areas of all the faces of your box. Okay, so in this case, you'd calculate the area of the top plus the area of the bottom plus the area of the right face plus the area of the left face plus the area of the front face, the front of our box, plus the area of the back face. So that's basically what we're actually doing. We are just calculating the areas of all these faces and we're just adding them all up together. Okay, so because we know that the top face, right, what shape is that top face? It's a rectangle. Okay, how would we calculate the area of a rectangle? So now we're going to just focus at the top, right? How do we calculate an area of a rectangle? So now you're just looking at this Benelin box from the top. So what can you see if you're just looking at this Benelin box from the top? You can only see the length of that box and you can only see the width. Okay, so to calculate the area of the top of our box, right, it'll just be length multiplied by the width plus. How would we calculate the area of the bottom? Still, if we're looking at the bottom of our Benelin box, so we are here at the bottom, so that's the bottom, okay, what would be the dimensions that you'd actually see? Okay, you'd literally just see still the length and the width. So it'll just be the length multiplied by the width plus. Now, we want to calculate the areas of the right and the left of this benevolent box, okay? Right? So still, if you're now looking at this shape that we have basically drawn for you guys here, right? We want to calculate now the area of the right as well as the left of this box. So what would be the dimensions that we would need to help us calculate now the area of the right and the left, okay? If you wanted to calculate the area of the right, so that's my right, okay? What are the dimensions that will help us to calculate the area of the right face, okay? It would just be that width there, and it would be the height. Okay, so then to calculate that area, it would be width multiplied by height plus. How would we calculate the area of the left face? Still, okay, the dimensions that we have, if we wanted to calculate the area of the left face, it's the width multiplied by the height. So it will be plus the width multiplied by height plus, okay? Now, we need to calculate the area of the front of our box as well as the back. So what do I mean by front and back? This is the front of the box and that is the back of the box, okay? So that is basically what I'm showing you here. How would we calculate the area of the front and the back? So I'm going to highlight the front and the back so that you guys see what I'm talking about. This is the front of our box, okay? And that is the back. Okay, so how would we calculate the area of the front? Okay, we have the length, that is the length, it will just be length multiplied by that height there, okay? Plus, how would we calculate the area of the back of our box? Okay, we still have that length there multiplied by the height. Okay, right? So in actuality, we can actually see that the top and the bottom of our box share the same dimensions. We can see that the right and the left side of our box share the same dimensions. And we can also see that the front and the back of our box share the same dimension. So instead of us writing length times width plus length times width, we can just say 2 length multiplied by width plus, okay, instead of writing width times height plus width times height, we can just say 2 width multiplied by height plus. Instead of writing length times height plus length times height, okay, we can just say 2 multiplied by length multiplied by height. Okay, so that is basically the trick in calculating surface area of a rectangular prism. It's just you being able to see that actually the bottom and the top of our box share the same dimensions. The left and the right side of my box share the same dimensions. The front and the back face of my box share the same dimension. And because those faces are a rectangular shape, right? We already know that when we're calculating the area of a rectangle, it is just length multiplied by breadth. So it's just you having to then determine from whatever face that you're looking at, what is the length and what is the breadth. Okay, so I hope I didn't lose anyone there. So that is how we basically derive the formula that we use when we calculating the surface area of a rectangular prism. Okay, let's just put this into practice. Let us calculate the surface area of a particular rectangular prism, right, by using just what I've explained to you guys. Okay, so we are basically given the following rectangular prism and we're asked to calculate the surface area of the given rectangular prism. Okay, so please note, okay, this is a rectangular prism, right, that is a closed box. So it's a closed box, right? So it has 6 faces that we basically need to consider when we are calculating the surface area. So now, how would we calculate now the surface area of this rectangular prism? We already know that when we're calculating surface area, guys, we just want to calculate the total areas of all the faces of this shape. Okay, we already know that the trick here is just being able to see which faces share the same dimensions, okay? And if you can do that, it just makes your life easier, because from there you just know that it'll be 2 times the top and the bottom area, okay? 2 times the left and the right area, and then 2 times the front and the back area, because we just know that we're just summing up, we're adding up all these areas together. And because the top and the bottom share the same area, it's just 2 times the area of the top, area of the top. Because the left and the right share the same dimensions, it'll just be 2 times the area of just that one side, okay? And then because you know the front and the back share the same dimensions, it'll just be 2 times the area of just one of those. So you don't have to now write it all out, okay? You can just shorten it in that way. Let's calculate now the total surface area of this shape. I'm going to start off with the the top and the bottom, okay? Because we see that the top and the bottom, you're looking at this box from the top, okay? So if you're looking at this box from the top, right, what are the dimensions that you would actually see, okay? Do you guys realize if you're just looking at this box from the top, okay, you will only just see the length of this shape and the width. Okay, so to calculate the area of the top and the bottom, right, because they share the same dimension, you don't have to write out the length times the width twice. You can just write, okay, length multiplied by width, okay, multiplied by 2. Okay, now okay, so because we see that the top and the bottom share the same dimensions, to calculate the area, we are just going to say 2, right, multiplied by, what is the length? It is 20 centimeters, multiplied by, what is the width? 8 centimeters. Okay, so I basically put that 2 there, okay, because we are just calculating the same area twice. Okay, so I don't have to write 20 centimeters multiplied by 8 centimeters plus 20 centimeters multiplied by 8 centimeters. I can just write it 2, open my brackets, 20 centimeters multiplied by 8 centimeters plus. Okay, now I want to calculate the total areas of my sides. Okay, so now here I see that, okay, the left and the right, okay, share the same dimensions, because we can see that here, if you were to just look at this box from the left side, you would only see the height of this box, which is 13 centimeters, and you'd only see the width of this box. So if you had to calculate now the area of that face, you would just then take that 13 centimeters multiplied by that 8 centimeters, okay, multiplied by 2, because we've got 2 of those, okay, 2 of those faces that share the same dimensions. So you can just multiply by 2, okay, and then here I'm calculating the area of the left and right, okay, plus what's left for us to calculate the area, okay, we just need to now calculate the area of the front and the back face, okay? So how would I calculate the area of the front and the back face? This is my front and that is the back face, right? So we see there that these two faces share the same dimensions, okay? And what would you see if you're just looking at this box from the front? You will literally just see that length of 20 centimeters and that height of 13 centimeters. Okay, so in this case, to calculate the area, it would just be that 20 centimeters multiplied by 13 centimeters. And because we've got 2 of those faces, we can just multiply it by 2 instead of writing out that value 20 centimeters multiplied by 13 centimeters twice. Okay, then here we're just calculating the area of the front and the back. Okay, so this is basically us applying what we've written there. Okay, we are just applying that in a literal question. Okay, so from here it becomes super easy. Just going to be substituting everything into our formula and then getting our final answer. Okay, so what is 2 times 20 centimeters multiplied by 8 centimeters, you'll get that you get 320. Remember, centimeters multiplied by centimeters is centimeters squared, plus 2 times 13 centimeters multiplied by 8 centimeters. This will give you 208 centimeters squared. Right? Remember, when we're calculating surface area, we are calculating area, okay, of all the faces of your 3D shape. So in essence, we are calculating area. So the units of measurement for area is centimeters squared, kilometers squared, meters squared, millimeters squared, depending on the units that you're given in your question. Okay, so in this case, because we are given units in centimeters, our final answer needs to be centimeters squared because we are calculating the total area of all the faces of the shape. We're calculating surface area. So it needs to be in centimeters squared. Okay, plus 2 multiplied by 20 times 13. Okay, if you punch that into your calculator, you'll see that you get 520 centimeters squared. So if you punch this 320 plus 208 plus 520, you'll get 1048 centimeters squared. So that is the total surface area of this rectangular prism. If you just sum up all the areas of this particular shape, it is 1048 centimeters squared. Okay, so I hope I didn't lose anyone with this explanation. I tried my level best just to help you guys even visualize what I actually mean when I talk about faces of a shape. We're just talking about that is the face of the shape. That is another face of that shape. That is another face of that shape. Okay, so that is basically what I mean by faces. So when we're calculating surface area, we're just finding the total areas of all the faces of the shape. And what is just important is that you don't have to write out now all the individual areas of all these faces. Okay, just to make your lives quick and easy, if you can just find the faces that share the same dimensions, if you are dealing with your rectangular prism, you can just multiply that by 2. Okay, and then we already know that when we're calculating an area of a rectangle, how did we calculate area of a rectangle? It's length times breadth. So you just need to determine what is my length on that particular face and what is my breadth on that particular face, and then from there it becomes easy peasy. Okay, lemon squeezy. Right, cool. So that is that for today's video tutorial. I think it was a bit long. I'm gonna cut it off here. In the next tutorial, I'm gonna be showing you guys how we calculate the surface area of a cylinder, what it actually means. Okay, in your mathematical literacy exams, the trick there is if you don't understand what is surface area and they tell you calculate the surface area of a given rectangular prism, if they maybe, let's say for example, they say calculate the surface area of this shoebox, if the lid on top of this shoebox is not there. So now if you're a person that just crammed formulas, you are not going to understand how you need to calculate that surface area. But if you understand what it means when you're actually calculating surface area and they tell you that you need to calculate the surface area of a shoebox, right? And then given that the lid of the shoebox is not there, then you'll just know that, oh, when I'm now calculating the surface area of the shoebox, I'm just going to be adding up the area of the left and the right face. I'm going to be adding up the area of the front and the back face and just the area of the bottom face because the top face is not there. So that is the trick. That's where they trick you. So you just need to be careful. It's not just about cramming our formulas, guys. It depends on what you are required to do, what that question is asking you to calculate the surface area of. Okay, what is that situation? Okay, if you're calculating the surface area of a cylinder, okay, is there a lid on top of that cylinder? What is actually happening with that scenario? So you need to be very careful. You need to understand really what are we doing when we are calculating surface area. So just be careful. Don't just cram formulas, okay? You just need to understand how do they basically come up with that formula. If you can understand that, you can calculate the surface area of any shape. Okay, so I'm going to stop it there, guys. Please make sure that you watch the next video tutorial because we're going to be discussing how we calculate the surface area of a cylinder. That is it, guys, and I'll see you guys on my next upload, Distance Learning with Lee, where I make learning mathematics super easy. Bye, guys.